everybody. We are really excited to be here. Thank you very much for attending. The title of our talk is Security the Cloud, Empowering Developers to Practice Security Chaos Engineering. Nice to meet you. We are Yury Nino and Jhonnatan Gil. We work as site reliability engineers for ADL Digital Labs, a company in Colombia that provides technology and innovation services. We are chaos engineering advocates. We are promoting the adoption of this discipline in our country. Cloud platforms are facing security issues that are frequently a matter for security engineers, not for developers. As a result, security is treated as separate from development. Today, we are talking about security chaos engineering, a novel discipline that offers a methodology to bring to developers to leverage the power of security in their roles. They are the topics for today. Jhonnatan will provide a foundation about cloud and security. He is going to show some keys from the well-architected framework. I am going to explore the integration between software development, reliability, and security. At this point, I am going to analyze why developers don't include security topics in their activities. With this context, I am going to present a novel practice named Security Chaos Engineering. Finally, Jhonnatan is going to show us how democratizing the security between software developers. He is going to show us the benefits from the distributed, immutable, and ephemeral framework based on Security Chaos Engineering. So go ahead, Jhonnatan.
Thank you, Yury, for this big resume. Hi, everyone. My name is Jhonnatan. I talk about the cloud and security and something is scenarios. We start talking about the wireframe architecture. This script about from AWS could be, this slide that talk about the architecture, about the excellence experience, about the security, or reliability, performance, and cost optimization. In these big steps that define every cloud, you need to know about how to work the security in everything that you need to adopt, right? Then we talk about bigger cloud providers, especially that is starting with AWS. AWS talking about the implementation of strong identity foundation that talks about the implement principle of least privilege and enforce separation of duties with appropriate authorization for each interaction with AWS resources. Centralized identify management and IAM use to eliminate reliance and long-term static credentials, right? The next, enable traceability, monitoring everything that you need, that you do in your cloud. It's a very, very needed to define in your infrastructure, right? And the next, apply the security in all layers. In AWS, you have a VPC, subnets, EC2 instance, S3, buckets. You could define in all these steps security in your IAMs group, security in your security group that allows who grant access for these resources. Next one, talk about the automate security alert. Yeah, best practice for security could be is when you try to automatize all things that are around of security. Then if you make this something, you could be better in your security, right? Protect data and transit and rest. It's very careful if you manage data very, very sensitive. Correct. And the next one, prepare for security events. Then train your team, train your people that know who is security and how to security and what is my business and how to the security could be safe my business, right? Because with security, you have a very big problem if your reputation is involved in some of security cases. And then practice that. And the next one, talk about the Azure security. Then talk about the defense in depth, protect your information from beginning, from installing individuals, who access for this data. It's very important. Define who access from these objects in a Azure cloud. And the next, identity management, benefits of single sign-on. Then manage all your access with controls, with AD, with your Active Directory, with your company directory. That's very good practice to access for this cloud. The next, talking about the infrastructure protection, define equals that AWS, define in deep how to protect all things that exist in this ecosystem. That's a very nice practice. Encryption, encrypt your data in rest, in transit. That it's very nice to have to do in your infrastructure. Network security can grant how access for your data, how access from your application, and how to apply some control of security that it's very nice to include in every part of your software. Application security, defined from requirement gathering, training your people to generate these requirements for the application that you generate. It's very safe from this beginning. Yeah, and the last one, talking about the GCP security, talking about for these strategies that define, implement the least privilege with identity and authorization controls. That it's same, but in other words, that define in other cloud providers. Building a layer security approach, implement security at each level in your application infrastructure, applying a defense in depth approach. Use the features in each product to limit access and use the encryption, right? Automate deployment of sensitive tasks. If you have tasks from your data, from generate reports, could be needed to generate some automatic tasks that the people don't execute these scripts. Could be because if the people access to these scripts, access to the data, it's very difficult control if you don't have a very granularity of these controls. Then if you have a very automated deployment, if you have a very automated this task, it's very nice to have because your security is better. Automate deployment of sensitive tasks, talking about implement security monitoring in all cloud providers. Define how to you deploy some things about the infrastructure, about your application. Then if you define, could be pipelines for generate these resources for my application, for my infrastructure, for my business objectives. Could be you define some tasks that they protect these steps in all things from security. That's right. And with that, you generate best practice for all your model that you define in your infrastructure and your business.
Thank you, Jhonnatan. Cloud computing models presented by Jhonnatan are dynamic and complex, which make difficult detecting threats and consequently to prognosticate cyber attacks. As a result, different systems are designed to respond to failures in quite different ways. In the absence of an adversary, systems often fail safe. Fail-safe behavior can lead to obvious security vulnerabilities. To defend against an adversary who might exploit a power failure, we could design the door to fail secure and remain closed when not powered. These primary reliability risks are not malicious in nature. For example, a bad software update or a physical device failure. In the other side, security risks come from adversaries who are actively trying to exploit system vulnerabilities. When designing for reliability, we assume that some things will go wrong at some point. When designing for security, I think it's different because we must assume that an adversary could be trying to make things go wrong at any point. Both security and reliability are concerned with confidentiality, integrity, and availability of our systems, but they view these properties through different lenses. They have traditionally been considered fundamental attributes of secure systems. The key difference between the two viewpoints is the presence or lack of a malicious adversary. A reliable system must not breach confidentiality accidentally, while a secure system must prevent an active adversary from accessing, tampering with, or destroying confidential data. Confidentiality, integrity, and availability are related with these two concepts: reliability and security. According to Google, reliability is the most important feature of our systems. Considering this, for reaching this, they must have to secure. Probably you are wondering where to begin integrating security and reliability principles into your systems. The first and the most important step is reducing security and reliability issues is to educate developers. However, even the best trained engineers can make mistakes. Security experts can write insecure code and SREs can miss reliability issues. Considering that it's difficult to keep the many considerations and trade-offs involved in building a culture based on secure and reliability systems in mind, we started making an evaluation of the situation in our company. So we applied a survey between developers with the aim to know how much they know about security and what is their perception about the importance of this topic. We interviewed 130 engineers in ADL, of which the 25% were software architects, 16% say they were front-end engineers, and 60% were back-end engineers. And just 2 or 3% say they were full-stack and quality engineers respectively. Although we were expecting that a percent of them didn't show interest in security topics, to the first questions, do you have interest in security topics? Almost 15 didn't have interest on those topics. That is an important percent if we consider that the group is mostly composed of backend engineers. OWASP is an online community that produces freely available articles, methodologies, documentation, tools, and technologies in the field of web application security. It is a great reference that all involved engineers in building of a digital solution should know. So we consider could make sense to ask about its practice. To our surprise, the percentage of people who didn't practice OWASP exceed 1/3 of the responders. About the static analysis is about analyzing and understanding computer programs by inspecting their source code without executing or running them. Static analyzers parse the source code and build an internal representation of the programs that is suitable for automated analysis. This approach can discover potential bugs in source code, but also it is a great tool to discover software vulnerabilities, preferably before the code is checked or deployed in production. To the question, do you run a static analysis? 23% of developers don't have security steps enabled in pipelines. This group includes 5 software architects, 14 backend engineers, and only 1 front-end engineer. 100 people have security integrated in the continuous integration, continuous deployment process. Finally, we asked them about the tools that they integrated into their development environments. In ADL, our Jenkins pipeline runs steps for measuring the quality of the code using Sonar. That is the reason for the first value, 49 of them use Sonar. But when we ask by tools or plugins for identifying vulnerabilities in the dependencies of the code, the values are low. Just 3 people use Black Dog and 2 use Sneak. Finally, just 1 person use Conf45 and Veracode, two tools for building secure software fast, finding security issues early and fix them. It is our conclusion of this survey. 14% of engineers don't show interest in security issues. That is really important because it imposes us a challenge, motivate and create culture about security between software developers. Group of people is mostly conformed backend engineers. That is an important thing to think about this. And we need to motivate them and we need to generate motivation strategies for them. So let me move another section of this presentation. It is clear that we have a problem from the development which can be extrapolated to the cloud. Considering that there are a group of people who don't show interest in security topics, the most probable is that an exploited vulnerability is only a matter of time. Software development is a dynamic profession. Source code changes daily and once in a while, so that's the way the local development environments needs to be set up. There are many benefits of integrating security in the development process. We have to rethink how developers see the cloud in terms of software development and adoption. In the early days, we performed the software development life cycle stages offline and on-premise, if you remember, where developers use their computers or terminals to access early versions of the World Wide Web, helping them find answers to problems or write software. Thanks to internet, software as a service solutions quickly brought significant security vulnerabilities. Nowadays, digital reliance throws upon business have served to how important secure software development life cycle is for business, customers, and society. A common security box can lead to catastrophic breaches if undetected. A 2019 study found out of 32 web applications, 82% of vulnerabilities were located in the application code itself. Hackers can attack users in 9 out of 10 web applications. Attacks include redirecting users to a hacker-controlled resource, stealing credentials in phishing attacks, and infecting computers with malware. Unauthorized access to application is possible on 30% of sites. In 2019, full control of the system could be obtained of 16% of web applications. On 8% of systems, full control of the web application server allow attacking the local network. On average, each system contains 22 vulnerabilities, on which 4 were of high severity. It is a fact we need to secure and guarantee reliability code. Today it has led to the growth chaos engineering, where resilience is built into code by designing and methodology. Security should be front of mind, both security engineers and developers. That is a fact. That is our conclusion of this first part. Organizations must offer training and culture internally. What can we do if there are developers don't like security, as I mentioned in the survey? We have a proposal here. Use security chaos engineering. Security chaos engineering is the identification of security controls failures through proactive experimentations to build confidence in the system's ability to defend against malicious conditions in production. This definition was provided in this book, Security Chaos Engineering, published in April of the last year. I have highlighted 6 words that are valuable in the definition provided by Aaron: security, failures, experimentation, and it is super important because this discipline is based on the scientific method. Confidence and defense because it is about to achieve resilience, and lastly production because the theory says that we should run experiments on production environment, although it should not be necessarily so. we can expect traditional teaching methods such as classroom-based learning to change a developer's mindset on secure coding. Gamified developer programs are a great way to engage developers and actively test their secure coding skills. Chaos Game Days are based on game days, and now I am going to provide some definitions related to that. A definition from AWS says that game days are an interactive team-based learning exercises designed to give players a chance to put their skills to the test in a real-world, gamified, risk-free environment. Most importantly, they are an extremely fun way to learn more about the potential of a technology. As a form of game days, Chaos Game Days is a practice event that can take a whole day. It usually requires only a few hours. The goal of a game day is to practice how you, your team, or your supporting systems deal with the real-world turbulent conditions. That is the objective of this practice. So it is a framework provided by Rules Miles. The framework has 3 phases: before, during, and after. During before, we pick a hypothesis, pick an style, decide who, where, when the event was run. So after that, during the during phase, detect the situation is the objective of this part, and other activities include take a deep breath, communicate, visit dashboards in the observability tools, analyze data, propose solutions, and apply it and solve the incident. And finally, the last phase is for writing a postmortem. So in this phase, we analyze what happened, what is the impact of the incident, what is the duration, what is the resolution time, and what are the action items included here. So let me talk about some examples for practicing security chaos engineering in a game day. One experiment for it is introduce latency on security controls, drop a folder like a script will do in non-production, software secret, clear text disclosure, disable service event logging, permission collisions, provide permissions collisions in, for example, in AWS, AP gateway shutdown, create an encrypted S3 bucket, or finally disable multi-factor authentication.
Impact of security chaos in general. In previous slide, we're talking about the chaos and how to this practice could be generate more value in your teams and generate some practice in our teams. And then now we're talking about how to our teams could be generate this value, these objectives with using chaos, and what could be generate this impact in our teams, right? Then could be one a big problem with this part is because you needed to talk a long amount of data to resume and correlation, generate some patterns about this data. You could be use BigQuery, use some other strategy from your cloud, and how to this cloud generate this pattern for me. That's not easy to use, but you can use and define what useful and what not useful for my cloud provider. Use this some a lot of resources that you can define and how to all part of the cloud generate this part for me that I not needed to generate very big tools. I can use some of IIA to generate this part of my data that I have in my storage, then how to correlate these logs and how to generate some part of my job more easeful, right? And the next slide, we're talking about the impact. What is the impact about the my teams? What happened with my teams? Talking about what is the most big importance with your requirements gathering and architecture design for security. This one is the part of focus from your software cycle, because you can prepare your people and generate some plans to this part. But if your architecture or the person that company, your business don't generate this value for the company, it's very difficult that view from all team, because all part of the team is very, very important in all part of the software, and you need to generate this value for your team, right? Then you need to generate plans to capacitate your people, and how to these people could be took these like a herd and generate these requirements the correct way, right? Then could be talking about the continuous testing, about this team that it's very important, but first focus obviously is the customers and the new features that generate with the value from the customers. But the second focus that generate for this team is the security. How to the security play a big important part of this scene, because that team could be generate more requirements for my development team that my business. Because if my team from QA could be generate these plans, some tests that generate could be some issues, the security could be my development team is more stronger when generate more software development for my customer. Then it's a very big part of my team, but it's important. Every parts of the team, obviously, it's very important. But if you generate focus in this part, the other part in your team generate this, because that cadence generate all the teams in the software development, right? An opportunity to involve of business, an example, asking if allow that login could be generated more from one browser, could be it's a one-off part that more than the other ways that the attacker could be generate some ways to this part. And in that part, you need to involve your customer in these requirements, right? We highly important of secure dependencies in time on software design and implementation. If you define in your team, in your software team, that use open source library, it's very carefully, because you needed to generate security for that. Yeah, it could be the team, the developer security, use open source library that generates some part of holes in my software, and it's very difficult to identify when your software is in production. But if you generate part of this definition of how to security these dependencies, how to could be generate some scan about this library, you generate more value from your customers and all value that you generate with your developer team, right? It's a very nice form to generate these impact. Talking about some recommendations that in ADL we generate with Yury and all security teams, that it's a very important in this moment, right? Use algorithm to protect sensitive data, use algorithm that use highest encryption keys, not 256 keys, could be in 1,000. Generate your proper algorithm that it's easy to decipherate for your team. Could be if your team of security is very mature, could be generate some algorithms to protect your data. If you have this part of your teams, very nice because it's part of the software too. Don't leave clear data in logs. Could be some developers use clear data to debug the application, but in production it's very other way, and it's very painful because if you leave clear data in logs, if these logs was stolen, you have a big problem, right? Then could be used more or less data included with the logs from your developer teams. If needed debugging in production, exists other ways to generate this debugging, how to your application use production for your development, right? Use MFA for critical application actions. Multi-factor authentication is a very useful for your actions, and not only for login. You can use this strategy for generate more secure approach in your software, right? Use a long, short, live, effective links for documents to be delivered. If you generate some PDF from your customers, could be generated a long time from these documents and of OTP, one access from these documents, and that's it. Remove from your storage. That is a good practice because you don't have to generate all things of this PDF, or could be other strategy is generate a hash. When the hash is get it from your customer, the system automatically generates the PDF, the customer download it, and you remove from your storage, and that's it. You don't storage this data because it's very sensitive and it's a very hard way to storage and maintain this data, right? Uses session management from front ends. Could be in this part separately. More your application generate backend, generate front end. If you can put some more layers from your application, from your front and your backend, because you generate difficult patterns from your hackers, that it's very hard way to generate some attacks from your application. Then if you use this strategy, you secure more your application, right? Do not use cookies and browser storage. Could be if you use storage and use cookies, could be not put in there some sensitive data. Could be put just a session ID, could be put a list of products or list of access from my role, but no sensitive data because it's very hard took from the computer's customers this data and replace that, right? And if an attacker take these cookies or storage from browser, it's very difficult remove that, and the customers are very painful because the customer generate new user, new password, generate some control that could be this have, and it's very painful for him too. Make all software activities auditable. If you have a software with all action auditable, it's very nice because you identify what the customer is doing in your software. In this way, you can define what happened if one customer access to unacceptable link and what tried to access to this link because they neither, right? Then you need to define this auditable from generate some alerts, generate some patterns from your customers, and how to define it's not a pattern from your customer, right? Perform vulnerability scan of the software, talking about the dependencies, is a good way to generate this part. Another part, enable CI and CD steps. If you have in this moment from delivery for your customers from your application, you need to enable these steps from security, that's very nice in your application, because you could be generate some politics about from the software, about the roles, about the how to deploy, about the how to secure my artifacts, my application, and how to generate these very secure. In these steps, that is a very previous from generate this software in production, right? Use hardening for validation of software elements. Could be used this hashing from your Artifactory repository that generate your artifactor, put in your Artifactory repository with the hash. When you download, check if the hash is changed, and that's a very easy control to your repository and your artifacts that generate too, right? Generate a container image in secure way. You could be use less access strategy of minimum of privilege from these containers, that it's very long way to your containers, but it's the good way from your customers and your application, because you don't have to generate these containers with the root access, because don't need it. The application really don't need root element with your environment, because if one application needed that, it could be already defined how to access from some resources in the container or from your resources, right? Separate environments from applications and separate database too. It's a very useful, this part, if you have a production environment, development environment, QA environment. It's a very easy part if you separate and isolate this environment from each one other. That's a very nice and very good way to generate this security, right? Then if you separate for less, just production and other environments in other part is right, because you could be generate some with this strategy, because I don't have a lot of money. That it's a good way and good some part to start with that. Use security blocking, user unsuccessful attempts. If you detect that your customers login from 3, 4, 5 attempts failed, you could be blocked, because it's a very good practice, and your customers is very grateful for you, because you can send email advice about your user has been blocking, about some attempts that could be don't generate, and these are alert from there for your customer. I'm very grateful, because it's a nice alert. And that's it, right? Thank you.